Welcome to another video about my operating system. This video, I thought I'd try something a bit different. Sticking with the whole live coding type thing, but this time I'm going to be doing stuff that's not in assembly. I thought I'd try a different language because I was getting maybe a bit bored of just working on assembly the whole time. But yeah, so this video I'm aiming to kind of work on this feature here of getting some debugging symbols. I'll just quickly show what I kind of mean by what I mean. So say let's do some C for now, but we won't be doing C later. We might just have a function like this, and I don't know, it might just add two numbers together, and then that's not yeah, that's better. Let's not bother returning anything there, but that should be an int. And here we can just return foo of, I don't know, not 1 and 2. Yeah, that's that one. Cool, so that is a little test program. Let's open up this and do that. And see, where is this even? Coding osdev. Coding osdev. Cool, so now if we compile that, actually make it return things. So if we do this, theoretically I think it will have a return value of 3, maybe? Yeah, cool. But what I want to kind of show you is if we open up old GDB on this application, so it says no debugging symbols, but really it does actually have not that one, does have some. So we can see that it's got a main and it's got a foo, and this is kind of what I want to have in my operating system when I'm doing debugging in GDB, and it can also help with other things such as backtraces. But yeah, so if we run this, we'll see we're in main. If we do a backtrace, it can see we're in main. If we go step, not step, let's just break on foo as well and continue up to there. No, let's run this whole thing again. Right, now we're in the foo, and we can see the backtrace. We've got foo and main, and that's kind of cool. So that's kind of what I want, is just getting literally these names here. Now you'll notice that when I compiled it, if you know C, I didn't actually compile with any debugging flags, but if we go -G for debugging and do that same thing, we'll see now it says reading symbols, and if we go main and foo, you'll see it also has line numbers and file numbers. That's also something I kind of want, but that requires a bit extra stuff that won't be covered in this video. But yeah, okay, we've just set 2 breakpoints, that's fine. Right, if we run that, and now you'll see that it actually shows kind of code highlights as well. If we do that, it does that. And if we go backtrace, it kind of has frame information, like it knows what the variables are set to. So that's something long-term future that we want. Maybe not so long-term, but let's stick with not having that. So just to see, it has the names of things, but not the actual line number information and stuff. Now, if we look at obj dump, if we look at this, kind of look at all the things, so it's got a bunch of stuff. Creates a lot of things for such a simple program. This font probably also doesn't help. There's also elf tool, read elf, that's the one I want. You can see I've done a bit of stuff with it before. What I might do is just compile GCC. I might just compile it, and so what they'll do is, if we remove the a dot out, we've got a test.o, test.o, which is a 64. What I might do is also do in32. So now it's a 32-bit elf, relocatable, blah blah blah. Got a bunch of stuff. Now the reason why I wanted to do that is if we go tools build, and then look in our build directory, and say, I don't know, drivers, and maybe our VGA driver, we actually clean stuff up in our build script. If we don't do that, and we run this again, then look in build. Yeah, so I don't know, we've got a kernel.o here, and if we look at that, that's very similar to, what was it, test.o. So a bit of a difference with this is that if we do that read elf of file.o, what do we want? We want like minus ws, so for wide display and symbols, I think we can find out what it is. So wide and sections, yeah. So I might. Oh no, that's good. That's good. Now, two things that are kind of interesting here are the sim tab and str tab. So why don't we have a look at that sim tab? Now let's change sim tab. That is starting at 130 and it is F0 blah. So this is what our symbol tab looks like, and we'll just get that str tab as well. And str tab was 220 and 3D. Right. So you see here that the str tab has all the strings. So it does actually have the file name, but it's not actually used, and it's also got this get PC thunk and global offset table. What I'm interested in this is just the foo and the main here. If we look at this and we also look at the symbol table, maybe side by side, and yeah, bump that font down slightly. And there was another read elf command I wanted to do. Yeah, this minus s. Yeah, so this minus s, if we look at the this is going to show us the symbols, which is exactly what we want. So here we can see the symbols. It's got a file, and it's also got a function down here, and the function's name is foo, and here the function name is main. And it's also got a size and a kind of value, which is where it is, which we can see if we I think we can just do like that, which is a bit weird, but if we break on main, that's at 22, and
foo is at 7, and that roughly matches up. Alright, ignore that one. But yeah, so anyway, I'm getting a bit sidetracked. What we have here is we have this foo and this main, and this is kind of what we want to build in our own sim tab for all of the so if we all of the assembly alpha files that we generate. So if we look at our build kernel.o, we'll see that it does have like it does actually have a sim tab. Wonder what that's got in it actually. Actually no, that it doesn't have a sim tab. That's just because I have the string sim tab in the source code, which is done from other stuff. And you'll see here it's got a few functions. Now that is done because I have actually done some work on this. I did some work on backtraces. And I kind of made some comments on that. If we look in here, we see that we've got like some symbols and stuff. The gist is that we have symbols. In fact, let's do a debug. So if we do a debug, we can see here. Oh man, this font. You'll see. Yeah, it's kind of got some things here, but not everything. What I might do is just do a reset there. I bumped down the font and that kind of ruined everything. I might, I don't know, in shell.asm, maybe in this process command, it'll hit like all the time, but if we just do a debug there, and kind of run there, you'll see we've broken on something, and we're broken on this int add handler and plus 240. Now 240 is quite a way away because this function that we're kind of stuck in is literally starts here, which I can let's go this way. In fact, let's get rid of this and cd coding osdev. So if we look at source boot includes, it's in a weird place, the handlers, but debug, no, it's break. Yeah, so this is where we are. So we're actually at the start of a function, but it thinks we're in this int add handler plus 240. Now if we search up for int add handler, it's here. And if we go kind of 240 bytes down from there, we skip over all of this stuff, which roughly, well, not 240 bytes, that's hex as well. We will get to where the debug handler is breakpoint. So as you can see, it doesn't actually get everything. And if we more I might need a fonts. Oh man, this is like, oh, I think it's done that. That's no good. Live demos. Yeah, hopefully this doesn't break the video. What is the thing I need to do? Display link. Restart. Basically, my external monitor docking station has broken, and hopefully we're still there. I'll have to check this later. But yeah, now if we do a debug call, that's a lot more responsive. Right, so we get here, and you'll see here it's got like plus 8,000, so that's like quite a lot more. Now, just to kind of show you how this is done, if we look in includes and public, I believe it is. So I've got some to-dos and the sections, and that's why those strings kind of appeared. But I've also got this debug functions that basically calls this function to like add stuff. Actually, no, this isn't why those names are in there. Those names are in there because I have test cases. In fact, yeah, so how we can reproduce this is if we go back to here, this is in like where did we put it? Let me do another reset. Int 3 shell process command. So if we do a public shell process command, that wasn't what I wanted, and do another debug. Just trying to see. Yeah, so here it now knows what it is. So that's kind of using a little macro to do it. What I want is to be able to have that without having a whole bunch of methods being public. So my idea for that is using fasm. So fasm has an output, debugging output. So if we go, I don't know, something like that, and I think it, maybe we'll do help. What is S? DBG. So if we do that and we look at this shell.dbg, it's a different format to kind of what GCC would generate. So GCC would generate the dwarf format, which is kind of what I mentioned here. But all we're wanting to do is basically generate these tables. So if we have a look-see back at if we have a look-see back at this and look at these two, we'll have a look at to see how that foo is defined. If we do that minus s again, we'll see the foo is defined like down here, and then the main is down here. If we get these two tables back getting displayed, so foo was, I think it was here-ish, just kind of guessing, but I also kind of know. So you'll see here it's got a bunch of fields. Now I don't actually know what they do. Documentation for this is not easy to find, but what I can see is it's got an index of 8 into the string table. And if we go here, this is 0, then 1, 2, 3, 4, 5, 6, 7, 8. So that is our 8th byte into it. Starts with a 0, so I think you kind of skip one more. But also I'm not too sure on the format. But if we look here, this is corresponding to this character here, and then we've got this foo afterwards. And then down here we have this 38, which if we skip 30, and that's 38 in hex, you'll see, you've got to see there. So if you go to 30, so 0, 1, 2, 3, 4, 5, 6, 7, 8, so that's here, and that corresponds to that little dot there, and then you got main. So that's kind of how you get the strings in. So in this video, I'm wanting to kind of get this file here, which is rather large because I picked one of the largest things. In fact, like, yeah, if I do this shell is like almost 1,000 lines of code. So what I might do is do a test.asm and need to have some boilerplate. I don't know, we'll just read in scheduler, sure. And I think that is enough for this. Right, so now we've got a foo, we've got a main, maybe we'll call foo, and foo can just do like red. Very, very basic program here, but my aim is to compile this. So if we fasm, well not compile, but if we fasm that, that should get a. Let's do a cleanup of this test.o because yeah, cool. So just to show the test.o is not here now, and when we do this fasm, it is there. And if we look at test.o, we've got a 32-bit elf, and if we go read elf on symbols, we see we don't actually have foo or main. So my aim is to get foo and main into this sim tab, which will involve getting str tab filled with str tab filled with the strings that we want. So now if we look at what these are, right, so str tab starts at 5c, man, it's a lot smaller, and it's 175, and sim tab, right, so that is 20, and that is 3c. Alright, so our sim tab is this, and if we look at this one again, nice small one that we can kind of see everything at once. And just to confirm that we're doing the same thing, this 11 should go into this byte here, so 10, 11, and that string there is dot text, which is what corresponds to there. Now, I might just scroll back up again. Oh, I probably shouldn't have outputted that. If we search for sim tab, goodness. You'll see here we want the type to be func, which at the moment it is not, and we can see here there's like some bytes down there and that will kind of set the type. In fact, we can probably guess that this 2 and 2 might be the func one. There is a 2 up there actually. No, we do have, so we've got 3 down there, so the 14, 12 and 11 are all funcs. So this one, and this one. So I'd say this 12 is the thing that says it is a function. I think that might have been... No. So one of these is the value. So you see you've got a 1b here, 1b there. So that's the value, that first column. And then the 3, 1 is the size, which is these 4 bytes likely, and that's the 2, 7 that you can see a bit up there. And yeah, so this 12 is saying it's a function, and these 2's, yep, the 2 is this like index thing here, which, I don't know, we'll have to work out some stuff, but what I'm wanting to do is basically get the names in. And we can see in our assembly one, we don't have much going on. But we do have this offset into here, and that has a name, so we can see we're reading the right tables. Now, when we assembled this, what we might do is, what was it, symbols, test.dg, and yeah, so if we have a look at this, oh, that wasn't the one we wanted, let's do one. Right, so this is like a couple of screenfuls of stuff, but you'll see here that it knows the file name we had, the object, bunch of stuff, and it should have a foo and a main. It kind of looks like the actual source code, but I am guessing that there will be some way to get those names out. And in here, this is, I might just put a link to, this was the one, fasm debug specs. Yeah, I'll just put that there. I guess I can put debugging symbols issue. Alright, but anyway, if we look at this, we've basically got saying what things are. So we've got a strings table, we've got a length of the strings table. So we could use this to basically get stuff out of that file. So if we go get that file there, yeah, so now we also have something here. I might just put that down here. Yeah. So we should theoretically be able to look up some of this information. Coding osdev. So if we remember how to do things, so if we go test.dbg, so we want to start at that is good. I had to do like a conversion from hex to decimal here, but this is just all in decimal, so that works quite well. Don't actually need to do the yeah, don't actually need to do that first tail because we're getting it from the start. But if we do this and look at that, right, so here we should have a little Indian signature of 1A736166 and 1A736166, and it's a little Indian, so we start from the right because that's where how little Indian works. If it was big Indian, it would be kind of reversed. So that is working pretty cool. If we look at the next four, and that's just 1 byte. So this is the major version of flat assembler. So that's like 1A, which I don't know, I'm struggling. 26, and if we look at fasm version, major version. I feel like, I don't know. We'll see what happens with the next byte. So that's also a 1. Maybe there was like, I'm not too sure, but yeah, the major and minor doesn't really work out. But if we look at 6 and it's got 2 bytes, this is our length of the header. So it's a bit, and it'll be low endian, so it's like print f, something like that. It's that many bytes long, and if we just do a quick sanity check of just debug, it doesn't actually have that much. I don't know, live demos. I haven't actually done this, but it's also getting a bit tedious kind of doing this cat to get everything out. So one point of this whole video was I was going to try a different language just to get my feet wet a bit. So it's something I've used before. It's called Porth. It's made by a guy on YouTube. And I guess we'll put a link to it. Porth source code. And he also makes a bunch of videos, Porth videos, that you can look on YouTube. I found it quite cool. It actually built up my confidence watching all of those videos to start working on my own operating system. It's something I've wanted to do for a while. So anyway, let's get Porth. So Porth is a concatenative, stack-based language, but concatenative language, concatenative language. Yeah, I might just do a add that to concatenative language and put that there and work out how to spell what? No, Z equal. I think I need to do a reset. I don't know why it's doing that so much. Yeah, that's what I want. I think I've just got it. Good concatenative. Yeah, my Vim dictionary just doesn't have it. Anyway, so we clone that there. So this language was originally written in Python, and now it's written in itself. So that porth, if we look at porth.porth, this is kind of what it looks like. This is a reasonably large file, like 5,000 lines. I was doing some work to kind of split it out into, I think that's somewhere else. He's got like a kind of beta copy he's working on, and this is the open copy of stuff released so far. But how we started, if we look in the bootstrap, there's a fasm file. So let's just compile that down. Oh yeah, you need to you need to bump up the memory because he has quite a large, yeah, that should do it. And so now if we look at bootstrap, there's another file there, which we can make executable, and if we run there, we're running porth, and we can compile that porth.porth, and that makes a compile version here. So we've just bootstrapped it, and you can actually, so it's self-hosting, so you can just do that porth.porth heaps and heaps of times. There's also some examples and stuff. So I don't know. One kind of cool thing is, hey, maybe let's do porth.porth. We can do the -r is to run. We can do game of life, and then that's game of life. And we can maybe make that heaps bigger and see what happens. Maybe not that big. Maybe like I don't know, 30 by 30. See what that looks like. Yeah, and it's got like some sweet gliders and they do some things. So you can do a lot of stuff. There's a bunch more examples. The rule 110 is pretty cool. So that's kind of two things that kind of prove the Turing completeness of it. But anyway, so what I want to do is get some stuff out of the test.debug. Let's look at the time. Right, so I've been going for half an hour. Yeah, so here we want to make a new, I don't know, we'll call it debug.porth. And if we, I haven't actually done this in a while. In fact, yeah, I was actually going to show off that as well. Where did I put it? GitHub, I think. github.com/u-import/advent of code 2020. What year are we in now? Ooh. Alright, I might have to just look it up. You'll see all the repos I have. I've got some pretty cool ones. 50 Shades of Security. Yeah, right, no hyphens in that. So I actually wrote a bunch of stuff in this porth for the advent of code. So I think I already copied that. So we'll go to here. Advent of code and my advent of code in porth. Right, so that's that, and yep, I did do it. Yeah, so advent of code is like kind of a programming contest where you have some input and you need to get some output, and it goes on for 25 days in December. So it's kind of like an advent calendar, except in programming, so you get one a day. 2021. So it's pretty cool. So this porth got written in October or November or something, and I was following along and I thought, hey, let's try it out. So I did advent of code in it. That's not what I wanted. This is what I wanted. I had some libraries that I made pull from here, which is like malloc, and I've got like a set and a map and a stack and some lists. Yeah, so anyway, yeah, do a reset again. Need to work out why I need to keep doing that. I reckon it's because of the font, but I normally have like that size font, which is just too tiny for videos, so I'll do this. So what I might do is just do like, I don't know, what's the fib.porth look like? Actually no, what's the website is probably a good one. He's got a web server example, which I find pretty cool in that language. Right, yeah, so it doesn't have the include. We need a prop main, and let's just do hello world. And so kind of the thing you do is, say if you want to add two numbers, you have to kind of do like that. What I might do is copy porth editor, porth.vim to vim syntax. I already had one, but set file type equals porth. I suppose I don't know, it's just doing some, but yeah, so, not printf. So, kind of my example is here, if you want to add two numbers, you have to kind of put the numbers first, then the operation. So you put a 1, then a 2, then you do a plus, that should get a 3, then we'll print that out, and then to print a string, you just put a string, then you do put set. Interestingly, if you put a string, and if we say print, what a string actually does is it puts the length in the character array just after. So if we do that and debug.porth, right. So I need to get that porth std. I did have some stuff to get that, but I might just copy this to here. So here, if we just look at what we were doing, so it printed a 3, then hello world, then a big number, then 3. So that was adding 1 and 2. We printed 3, then we printed hello world, then ABC. We printed the character array first because it pushes the length in the character array. So the character array where that is, then we printed the length, which is 3. Now, an example that might be useful would be cat.porth. So this is reading a command. So this so that's he's got a little thing there. So we need to open the thing. This is potentially not a great view, but I thought I'd give it a go because I don't know, try it out. Haven't done porth in a while, feeling a bit rusty. My aim is to get this test.debug. I want to read that file, so I might just hard code that. Actually, no, I won't hard code it. In fact, let's just start from porth examples cat. We'll start from this guy here. So this is what we want to do, and we will kind of change what we're doing in this actual cat part. So if we run that and debug, test.debug. Right, so that's just printing it out. It's basically doing the same as that. I'll do a reset because that probably screwed up a bunch of stuff, and I don't know, this video just needs lots of resetting. So now what I want to do is do some cooler stuff. So we've opened this file and say we want to, we basically read the entire file into so we read in a buffer full at a time. So I'm going to basically change this to do something different. So if we do this vim, why don't we try and get that signature first? So we want to read 4 characters, so it's 4 bytes, and we'll read it into buffer and we'll read. So now if we, buffer is memory. Yeah, so it's got this kind of cool command. The question mark. So this is a statically typed language as well. Run this file on test.debug. And that question mark, set of question marks, that's probably easier to say, that will show me what's currently on the stack. So we've got a kind of one integer there. So if we print that out, what that's saying is we've read 4 bytes, and that buffer should show those 4 bytes. So if we go buffer and like 3 plus and read that as a byte, and then print that and do that, and I guess drop that, because one thing with the language is if we don't have that drop, it will just not. Right, that's a different thing. These all need to be that statically typed. So this buffer is a pointer, memory pointer. So to add stuff to it, you need to do that. But now it should also complain because we've still got an int on the top. So we just need to drop that there. In fact, we don't really need it here, so we could drop it here. So this is kind of stuff there. Now, I want to write that in hex if possible, but I can't remember if there was a porth std. Nah, I don't think this has like a 2 hex. We could write a 2 hex. So like hex chars, and that can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F. Proc 2 hex, and that is going to take a integer, and it's going to return a integer and a pointer, which is basically a string. Right, live coding, and down here we will be going to hex and puts and get rid of that, and also that one there. Right, so here we want to take a hex, take an integer, and then get a hex string. So what we need to do is,
I'm going to assume that it's... no, I can't really do that. Yeah, so I guess what we need to do is... yeah, we do have comments, I think. If we, I don't know, drop... do that. 6. They're not. Alright. That's not great. I don't know. We won't actually. We'll just print it out. And what we can do is over here we can just check what it is. So we've got a 1A, we've got a 115, 73, we've got a 97, 61. It's all looking good up the top, and 66. So that's all looking pretty good. Yeah, I kind of want to... yeah, I could do that off screen. But yeah, we'll leave it for now for that. Right, so that is the magic. What we really could do is check that the magic is what we expect. So if we print f 1a not equal if exit 1. Now we probably should proc end. We'll just do that for now, and 1 exit. End. So what they'll do, say if it's 25, they'll panic and we'll return 1, but it should actually be 26. So we'll do that, and it is correct. And what's the next byte? 73, 115, and then 61, and then 66. So 115 not equal if panic end. 97 not equal if panic end. And 102 not equal if panic end. Right, so that's basically checking our magic, which I think we could, well, we'll check that it works. Magic, okay. So if we do that, magic, okay, cool. So what we might do is break that out into proc verify magic, and we'll maybe take the file descriptor. This let is basically binding something on the stack. So at this point here, we've got one on the stack, which will be the file descriptor, and then at this point here, we've got nothing on the stack. So in fact, if we do that, yeah, current stack state is like empty. So what it's done is basically take it off and bound it to that variable. So now we can just write fd, and that will put it back on the stack, so we can use it for other things, which we will do here. And I think I might
So I might throw on a true onto the stack, and do this style thing. Yep, that is what we want, and we want that to be that, and then 5, and that, and 97, and that to be that, and what was it, 102. Yeah, so I think they'll do what we want. So now we want to kind of just do fd verify magic, and then if do that else magic failed, oops, and we can do a panic. So I'll keep the panic in there just because I kind of like it. And I think they'll, yeah, cool, so that works. And if we, I don't know, check the wrong byte or something, then magic failed. We potentially could check the right thing, but yeah, we'll do that. Fd is at offset +4. So what I might do, coming up to an hour of the stream, I might actually bail here, because I've got kind of a start of a little debug thing, and I'm hoping to kind of continue on that, and yeah, work through that debug format to get more stuff out, using this porth language, just for a bit of fun and doing something a bit different. The reason why I'm not using assembly for this is because it's going to be part of the build pipeline, which if we look in the build pipeline, we're using shell script mainly. At some point I'll replace this with assembly maybe, or I might replace it with something else, I don't know, but yeah, thought I'd try porth, because it's good to kind of try different things for your brain. What I might do is lots of stuff. So we might just do this debug.porth. We'll add that to the thing. Have a look at what we've done. That's right. We'll get rid of that, so it's just got that now. I'll clean up this test.c and shell out the bug, and what's that debug.asm I had? Oh yes, that's kind of one side thing of porth is it will generate a assembly file. So it basically compiles down to assembly. So this is that debug file that we have just written in the last half hour, and it does a bunch of stuff. It's 18,000 lines of code. He's working on optimizing it in the beta version, so I'm looking forward to that. But yeah, we'll keep that in there, and I don't think I'll add any of the other stuff, so I'll basically just add that. Of course. I don't know. I should do that. I should work out why it's kind of failing. Pre-commit.
so if we did that now, cool, we can just add that. So what I might do is kind of add that, add start of debug.porth. This file is going to parse the fasm debug symbols file to populate the str tab and sim tab sections of an F file. This will allow us to have symbols in our debugger that doesn't rely on key public characters. Let's like close it. I don't really want it to close it, but like 28. Yeah, I kind of want it to just have it. Do that, and yeah, I might finish up the video there, and thank you very much for watching. And feel free to leave any comments what you like, and just let me know if you're enjoying the content. Otherwise, have a great day. See ya.